Hello and welcome to the feedback video for assignment 6, Momentum. In this video we're going to look at the questions indicated here. At the end of the video you'll be asked to complete a question that includes some similar concepts. Please pause the video, attempt the questions and hand them back to your teacher as soon as possible. The first question is a fairly straightforward one, asking you to calculate Richie McCaw's maximum momentum. This would be when he's running at his maximum velocity. For any calculation question though, we should first list our variables, and from the question above we can see that his mass is 107 kg and his maximum velocity is 9.0 meters per second. Momentum is the product of these two values. That is, momentum is equal to mass multiplied by velocity, and that gives us a maximum momentum of 963 kilogram meters per second. The unit is kilogram meters per second, as that is the SI unit of momentum, and the units of the two numbers we have multiplied together were kilograms for mass and meters per second for velocity. Students most commonly miss out the direction of momentum. We must remember that momentum is a vector quantity, and so the answer is not fully correct without a direction. If you are not specifically given the direction in the question, like left, right, east or west, then use the question to gain a reference position to state direction either towards or from. Here I have used the player as my reference point and stated it as towards the player. The momentum is in the same direction as the velocity. The second question is again another fairly standard question and wants us to define the principle of the conservation of momentum. Momentum is a very important quantity in physics, and just like any other conservation rule, it states that the amount of momentum before a collision or explosion is equal to the amount of momentum after a collision or explosion. As for assumptions made, or situations when we have momentum being conserved, the interacting system must be a closed or isolated system. That means that the sum of the external forces acting on the system is zero, or we can say that there is no resultant external force. Be very careful with your words here. We are talking about the sum of the external forces or the lack of a resultant external force. In the third question, we are dealing with a collision, and we are going to make the assumption that there is no resultant external force acting on either of the players. Here, on the diagram, I will indicate direction of their velocities. This is important as we are dealing with vector quantities. I will also define which direction will be positive for my calculations, and all variables acting in this direction will be positive numbers, and therefore all variables acting in the opposite direction will become negative values. First, let's list all the variables from the question and the variable we are trying to calculate, which is the velocity of the player trying to stop Richie McCaw. The real physics of this question is to do with the conservation of momentum, and that is that the total amount of momentum before these players collide must be equal to the total amount of momentum after they collide. The player wants to bring Richie McCaw to a stop with a velocity of 0 meters per second. At the bare minimum, he must provide enough momentum in the opposite direction before the collision to counter that of Richie McCaw. This would mean that there is 0 momentum before and after the collision. To therefore calculate the velocity, we must first write an expression. Here we can state that the total momentum before is the same as the total momentum after the collision. And as explained before, after the collision, McCaw and the player would have 0 momentum at the player's minimum velocity required to stop McCaw. So by adding McCaw's momentum he had before and the player's momentum before the collision, they must equal 0. Hence the player's initial momentum must be equal but opposite in direction to McCaw's. After a rearrangement and substituting the known player's mass in, we can calculate a negative velocity of 9.8 meters per second. This negative means that the velocity is towards McCaw, as we previously defined this direction as negative. As for identifying the type of collision, it would have to be in one dimension and it would be an inelastic collision, as kinetic energy is certainly not conserved. They both previously had kinetic energy, and now with zero velocity they have none. This kinetic energy will have been transformed into heat and sound. Okay, if you could now pause the video, attempt the question and hand it in to your teacher as soon as possible.